Unit 2, Introduction to Drug Therapy, Section A and B Calculations. These are your objectives and these are your reading assignments. Section A, Decimal Points. Please review your decimal points and really be familiar with calculating them and how to round numbers into the nearest tens, hundreds, and so on. So looking at this is your decimal point, and the number to its left would be the ones, and then followed by tens, hundreds, thousands. Now, going back to the decimal point again, the first number to its right would be the tenths, followed by the hundreds, thousands, and 10,000s. In this course, we're going to be using or rounding most of your calculations answers to the nearest tens or hundreds place. So please, again, review this, be familiarized with it, be more comfortable with rounding decimal numbers. Speaking of rounding, in this course, you have to remember these rounding rules. So in documenting with calculations, all your answers must be labeled correctly for what you are solving, unless otherwise specified that you don't have to write the unit of measurements. But in your assignments, in your worksheets that you're going to be answering at home, you have to write the units of measurement. Number 2, do not round any numbers until the end of the problem unless you are converting weight. If you are converting weight, please see number 5. So again, ideally, you don't want to round until the very end or unless you were instructed to do so. Number 3, basic rounding with decimals. So you shouldn't put a 0 after a decimal point. So no trailing zeros and no naked decimals. So let's say the answer is 4. It's incorrect to write 4.0. So if it's just 4, right, just write the number 4. Because that way you will avoid any potential errors. Because the last thing you want is when you look at the 4 and then for some reason whoever is reading it or the order or whatnot, they don't see that decimal point, then they're going to think it's 40. So it's better to just write the number the way it is, 4. Now, if we're talking about decimals, so if your answer is less than 1, let's say it's 0.12, instead of writing 0.12, you have to write the 0 before the decimal point because it kind of tells the person reading it that it's actually a decimal. So the correct way of writing that would be 0.12. In addition, rounding to the nearest tens. If the digit in the hundreds place is equal to or greater than 5, you need to round up. Example, if the answer is 1.57 and you have to round to the nearest tens, you're looking at the 7 over here, so after rounding, you're going to end up with 1.6. Now, if the digit in the hundreds place is less than 5, you round down. Well, example would be 1.54. So looking at this number over here, it's less than 5. So knowing that we have to round down. So now our answer would be 1.5. Rule number 4. If we're talking about liquid medication, if it's greater than or equal to 1 ml of fluid, you have to round to the nearest tenths place. If it's less than 1 ml, you have to round to the nearest hundreds place. And the main reason for that rule is because you want to be as accurate as possible, and at the same time, you want to look at the instruments that you're going to be using. So let's say you have to draw up 0.34, right? If it's less than 1 ml, you're going to need to use the 1 ml syringe, which will allow you to measure it to the nearest hundreds. On the other hand, if your answer is 1 or above, when you're looking at the equipment that you're going to use, which is the 3 ml syringe or more, right, you can't usually measure to the hundreds place. You can only measure as far as basically the tenths place. So that's the reason why that rounding rule exists. Converting the weight. Do not round until the end of the conversion. And then round weight for adults to the nearest tenths. And then for pediatrics, you have to round the answer to the nearest hundreds. Do not ever round pediatric weight to the whole numbers, because that could be a significant change in the medication dose for that patient, and that can be very detrimental for your pediatric patient. Capsules and tablets. So for capsules, this must be rounded to the nearest whole number. And for tablets, unless otherwise indicated, we need to assume that the tablets are going to be scored, and we need to round to the nearest half a tablet. So when we say score, when you're looking at the tablet, it's this line in the middle. So whenever a tablet is scored, it means that you can actually cut it. If it's not scored, those tablets cannot be cut or crushed. Systems of measurement. So these are the common conversions that you actually have to remember. So for this course, please remember this. For 1 kilogram, that's equal to 1,000 grams. It's also equivalent to 2.2 pounds. 1 milligram, on the other hand, is equal to 1,000 micrograms. 1 gram is 1,000 milligrams. 60 milligrams is equivalent to 1 grain. When it comes to liquids or volume, 1 ml is equal to 15 drops. 1 ml is also 1 cc or 1 cubic centimeter. In all honesty, we don't really use this anymore, but some of the older doctors or nurses that have been practicing for quite some time, you still hear them say, let's say if the order or if they said, oh, you need to drop 1 ml, instead of saying 1 ml, they will sometimes say 1 cc. So that's what it means. Cc is ml, and cc stands for cubic centimeter. 1 ounce is equal to 30 ml. 1 teaspoon is 5 ml. 1 tablespoon is 15 ml. And 1 liter is equal to 1,000 mLs. For the length, we rarely have to use it. Actually, I don't think we'll really use this for this course, but it's also good to know. 1 inch is equal to 2.5 centimeters. So know how to convert pounds to grams to kilograms. Grains, it's still occasionally used for certain medications. It's not as common, but it is written as GR. Volume, we talk about cc. It's actually no longer acceptable, but like I said, people still use it, so it's good to know. And then again, talking about 0, before a decimal, for number less than 1, make sure you include it, but don't include it if it's after the whole number, a whole number. Fractions use decimals for volume of liquid, so remember this. Again, decimals if it's liquids. But if we're talking about solid medications such as tablets, pills, then it needs to be in fractions. So let's say your answer is half a tablet. It's not going to be 0.5 tablet. It needs to be 1/2, right? Half a tablet in fraction form. MEQ means milli equivalent, and this is used for electrolyte. It's a unit of measurement used for electrolyte. It's commonly seen in potassium chloride. Let's briefly talk about dimensional analysis. We are going to talk about the steps, but we're going to go over the actual calculations in class because I think that's easier rather than recording it. I think it's good to go over it step by step together in person. Anyway, so dimensional analysis, this is going to be the method we're going to be using in calculating our medications in this course and throughout your stay in this nursing program. So dimensional analysis uses the ordered amount of a drug to multiply with 2 equal quantities in different dimensions, so unit of measurement, to derive the answer. The physician or provider always includes both a quantity and a dimension in each medication order. So if you focus on the dimension rather than the numbers, you can create a template to use for every problem. So dimensions or units vary depending on the circumstance. They may be tablets, capsules, bottles, mLs, ounces, tablespoons, milligrams, grams, grains, or something else. Calculating the dimension analysis can be done in 4 steps. So number 1, write the unit of the dose ordered. Step number 2, write the units that are on the label and the unit that you plan to give to the patient. And then step 3, now fill in the numbers for each unit and cancel the ordered units. And step 4, check your work for accuracy and sense. So this is how you're gonna set it up. So it's up to you. You can use this or the other. But basically when you're setting it up, right, you have to decide what numbers to go on top, what numbers would go at the bottom. One method is starting with your supply, so how the drug is supplied. So if it's in ml, tablet, whatever, right? Over how much is in the supply. So let's say it's a 500 milligram tablet, then one tablet goes on top over here, and then 500 milligrams goes at the bottom, multiplied by the desired dose, so the ordered dose, so let's say it's 250 milligrams over 1, and that way you can actually cancel this 2, right? They cancel each other, they have the same measurement because we want to end up with tablet. And so your answer would be the amount that you need to administer to your patient. So again, this is basically the same thing, kind of reworded so it's easier to understand. Another way of doing it is starting with what do you want or what was ordered by the provider over 1. So let's say they ordered 250 milligrams of whatever tablet, right? Then 250 milligrams goes here. You multiply it by how it is supplied. So what's on the label? So looking at the label, again, if there's one tablet is worth 500 milligrams, then the tablet goes up here. And then for the denominator, you're going to use the 500 milligrams. And then you multiply across, and whatever your answer, that's the amount of medication that you're going to be using. So either way, whatever you choose to do, however, if you want to decide to go with this or this one over here, you should come up with the same answer. So in class, we're going to go over these examples, and definitely I can help answer some of your questions. So this is another additional information or a guide regarding dimensional analysis. Please read it. I wouldn't really go over it again just because I already spoke about them. Just read it for your convenience to kind of help you understand it a little bit better. But the examples, we're going to go over it in class.